Today we are going to continue with the study of trigonometry. We are looking at the general angles and the trig ratios in the quadrants in a circle. We're looking at general angles and the trigonometric ratios in the quadrants. We will take the first case. Here is the circle, and then we have here the line OP, which is the radius of this circle. The line OP is making an inclination of theta with the x-axis, the horizontal. The point P is a variable point, and this is in the first quadrant. The circle has been divided into 4 equal parts. The first part here is the first quadrant. And then from this point of the first quadrant, we have here at 0 degrees, and going anti-clockwise to this point will be 90 degrees. So we are talking about the theta being between 0 degrees and 90 degrees. From here you have a triangle OPN. And of course PN is perpendicular to the horizontal, as indicated in the diagram. The value from O to N is S, while the value from N to P is Y. And of course, from O to P is the radius of the circle, R. So, from the first quadrant, which lies between 0 degrees and 90 degrees, we have the ratio, the trig ratio, sin theta, is equal to, remember, opposite over hypotenuse, and that is represented by Y and R. So we have sin theta is equal to Y all over R. Similarly, cos theta, in the same definition, remember our SOHCAHTOA is adjacent over hypotenuse. That gives you S all over R by the representation we have in the diagram here. The same thing goes with tan theta, and here tan theta is opposite over adjacent, which is Y all over L. You will now see in this first quadrant that all the trig ratios are positive. All are positive. The sine, the cosine, and the tangent, as you can see from their ratios. Now, we move on to the second quadrants. The same diagram, this time around, we have our OP as rotated to the second part, which is the second quadrant. Now what happens? You now discover that the value from O to N is now minus S. And then the value of Y, the vertical still remains the same, the Y. And then the radius remains the same as R. Now, our angle theta has now moved up to this point. In this time around, this is no longer an acute angle. It is now an obtuse angle because it is more than 90 degrees. That reminds me, in the first quadrant, we actually see theta as an acute angle. Please don't forget that. Let me still write it here, acute angle. This is acute angle. In this case, the second quadrant, we are talking about obtuse angle. Take note of that. Obtuse angle lies between 90 degrees and 180 degrees, and this falls in the second quadrant of the circle. In this case, our ratio sin theta will be equal to sin 180 minus theta. Why? This is the angle theta. We are now looking at this angle here, which means moving from here to here is 180 and going back. So when you subtract theta from 180 degrees, you will have this angle in the right angle, the triangle indicated in this plane. So we can now find the ratios using the right angle, the triangle. In other words, our sin theta will now be equivalent to sin 180 minus theta, and defining sin theta in this case of 180 minus theta, it becomes Y all over R. Similarly, cos theta is cos 180 minus theta, which now also is defined as minus s all over r. And then tan theta is tan 180 minus theta, which is also equal to y all over minus s, which is written as minus y all over s. You now discover that only sine is positive in this second quadrant. Let us now consider the third quadrant. This time around, our OP has rotated to the third quadrant. The representation remains the same. The radius is the same. From O to N is minus S, and from N to P is minus Y. Now, it is now lying between 180 degrees and 270 degrees. Now, this arc indicates that it has rotated to this point, our theta, which means we have moved from 180 plus another value. So let us call this our theta. Now, in the third quadrant, what now happens? Third quadrant lies between 180 degrees less than theta and less than 270 degrees. This is a reflex angle. The first two cases we consider, the first was an acute angle, the second was obtuse angle, but this is a reflex angle. You remember your reflex angle, an angle that is more than 180 degrees but less than 270 degrees, or less than 360 degrees, and this one is within that range. So, under this, we can consider sin theta. Our sin theta now is equivalent to sin 180 plus theta, because the rotation, we completed 180 plus another value. So we now say 180 plus theta. And then looking at sin theta, as far as we are concerned in this case, is considering the triangle there, is opposite over hypotenuse minus y all over r. Similarly, cos theta is equal to cos 180 plus theta, and that is minus s all over r. Then tan theta is the same thing as 180 plus tan 180 plus theta, and that is minus y all over minus s. Minus and minus will cancel, giving you y all over s. You now realize that only tangent is positive in the third quadrant. We move on to the fourth quadrant. The diagram is here represented. And now look at it. The angle, we have now moved from first quadrant to second quadrant to third quadrant. We are now in the fourth quadrant. So let's call this angle in the triangle theta. It's like moving from here to here is theta, and this as moving from here to here is 360 minus theta. So in the fourth quadrant, take note, we are talking about angle between 270 degrees and 360 degrees. This also falls into the range of the reflex angle. So in the fourth quadrant, we have 270 less than theta and less than 360 degrees. As I said, it is a reflex angle. So we have two reflex angles in a circle, the third quadrant and the fourth quadrant. Our sin theta here is equal to sin 360 degrees minus theta. And then, if you look at that, that gives you minus y all over r. Similarly, cos theta is cos 360 degrees minus theta, and that gives you s all over r. And then tan theta is minus y all over s, the same. So you discover that only cosine is positive in the fourth quadrant. Let us now summarize what we have discussed so far. In this diagram, you have starting from the 0 degrees to 90 degrees, first quadrant, 90 degrees to 180 degrees, second quadrant, 180 degrees to 270 degrees, third quadrant, and from 270 degrees down to 360 degrees, the fourth quadrant. And I've written inside each of the quadrant letters. The first quadrant has letter A, the second one letter S, the third one letter T, and the fourth one letter C. What does this represent? The A here represents that all the trig ratios are positive in this quadrant. all the trig ratios are positive here. That is sine, cosine, and tangent are positive. While in the second quadrant, S stands for sine, only sine is positive here. Others are negative. The third one, this represents tangent. Only tangent is positive here. All others are negative. While the fourth one, C represents cosine. Only cosine is positive here, while others are negative. So in other words, using a mnemonic, we can say cast, starting from the fourth quadrant and going anti-clockwise, cast. Or we can start from the first quadrant and go clockwise, axe. So any of them you recall will be able to give you an idea of what is positive or negative in the various quadrants. So you can say cast or axe as represented by the diagram here. Now, we want to quickly look at the reciprocals. Sine, cosine, and tangent, they also have reciprocals. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. In other words, cosecant is the same thing as 1 all over sine. Secant is the same thing as 1 all over cosine. And cotangent is the same thing as 1 all over tangent. Now the reciprocals are also positive in the various quadrants. What do I mean? For the first quadrant, cosecant, secant, and cotangent are all positive, just like sine, cosine, and tangent. In the second quadrant, only cosecant is positive. Cosecant is the reciprocal of sine. So as sine is positive, so also cosecant, which is the reciprocal of sine, is also positive in the second quadrant. Third quadrant, only cotangent is positive. Just like tangent is positive in the third quadrant, so also cotangent is positive in the third quadrant. Then the fourth quadrant, only secant is positive. Secant is the reciprocal of cos or cosine. So cosine is positive in the fourth quadrant, so also is the reciprocal of cosine, which is secant. It's also positive. Examples. Example number 1. Evaluate sine 300 degrees. Solution. You will recall that 300 degrees is in the fourth quadrant. So our sine 300 degrees is equal to sine 360. What will you subtract from 360 to get 300, which is 60 degrees? And in other words, this will become minus sine 60 degrees. Remember that in the fourth quadrant, sine is negative. That is why I put the minus sign here. And so that will give us minus root 3 all over 2. This is the third equivalent of the result. Or we have this as minus. Find the value of sine 60 from your figure table or your calculator. You have minus 0.8660. And this is also correct. So sometimes the question can demand or request you to solve the problem, leaving your answer in the solved form. And then you can leave it at this point. But sometimes they can go further and ask you to find your answer, maybe correct to 2 significant figure or 3 significant figure. It means that you require this one before you can correct to either of the significant figure that is allowed. Example number 2. Evaluate cos minus 170 degrees. Our solution. When an angle is negative, it's only indicating the direction of measurement. When angles are measured clockwise, they are negative. If they are measured anti-clockwise, they are positive. In this case, this angle has been measured clockwise. That is, you have something like this, and the angle was measured in this form, 170 degrees. And this is the angle. So this is 170 degrees. But because of the direction of measurement, it is minus 170 degrees. All we need to do now is to find where the quadrant lies. If it is negative, all you need to do is to convert it to its positive equivalent by simply writing your cos minus 170 degrees will be equal to the cos of minus 170 plus 360 degrees. Now when you add this to the minus 170, you will have made it positive. So let's just add this. So what will you have? You now have cos. It's like subtracting 170. If you like, you can write it as 360 minus 170. In other words, this becomes cos. Subtracting that is 0. Subtracting that will give you 9, and then you have 190 degrees. At this point, you still have 190 degrees as an angle that is more than 90 degrees. So we can convert this one to its acute equivalent by writing this as cos of 180 plus 10 degrees. 180 plus 10 degrees. And of course, recognize that you have passed the second quadrant, you are now in the third quadrant. And recall, in the third quadrant, cosine is negative, so it becomes minus cos 10 degrees, the acute equivalent of 190 degrees. So, in other words, you will now calculate the value of minus cos 10 degrees by checking your calculator or your four-figure table. Let's do that quickly. We now have cos 10 degrees will be equal to 0.9848, and then the minus, which is 10, and this gives you the value of cos minus 170 degrees. Example 3. Find theta, given that sin theta is equal to 3 all over 5 and tan theta equal to minus 3 all over 4. Our solution. First and foremost, we have to identify the quadrant that sin theta and tan theta belong. From what we can see, we know that sin theta is positive in first and of course the second quadrant. Okay. Then your tan theta is negative in the second and fourth quadrant. Alright. In other words, we are interested in the common ground, the second quadrant. Therefore, your sin theta and your tan theta is in the second quadrant. Alright. Now that we know this, so whatever value we get, therefore, your sin theta equal to 3 all over 5, which is equal to 0.6, and therefore your theta is equal to arcsin 0.6. And what is the value of arcsin 0.6? From our calculator, we get our arcsin 0.6 will be equal to 36 and then 0.87 degrees. You can decide to correct this to 2 or 3 significant figures, and then the answer becomes 36.9 degrees to 3 significant figures. Or you can take your tan theta is equal to minus 3 all over 4, which is equal to minus 0.75. So, ignoring the negative sign, then finding your theta using the positive value, so theta will be equal to arctan of 0.75. Then again, we go to our table and we find the value of arctan 0.75, and that will give you again 36.87 degrees as far as this case is concerned. But you recall that, as we said earlier, in the second quadrant, that is where the solution lies. So in the second quadrant, we have the answer as follows. Therefore, in the second quadrant, your theta is equal to 180 degrees minus 36.87 degrees. And whichever way, what will you have? Let us subtract that. So we have 180 minus 36.87 degrees. And that will give you 143.13 degrees. Of course, you can correct this to 3 significant figure, and that will give you 143 degrees to 3 significant figures. And this gives you the solution to the problem.